bearings. In the diagrams below, find the stated bearings. So I decided to summarize these questions instead of presenting them in the usual way where they give you the bearing of P from Q and ask you to state the bearing of Q from P. So I want you to understand them as opposed to memorizing the direction of this arm. If this arm is this side, you do this. If this arm is on the other side, you do that. It's better to understand them so that in case they decide to twist it the way they did in 2014, like for this one, oh no, 2024, you are still able to solve it. So let's start. The first one is states the bearing of P from Q. So to state the bearing of P from Q, this one is easy. What you do is you go to Q and then you draw a north line if it's not there. Fortunately, we have a north line on Q. So your job here is to draw an arc from here to there. We already have one, so your job is to just state whatever you've been given there. So this angle here is 157 degrees, and that's your answer. It's that easy. And then on part B, you want to find the bearing of Q from P. So what you do here is you go to P. Remember, you are coming from P going to Q. If I say Lusaka from the copper belts, for example, I mean you are coming from the copper belts and then going to Lusaka. So the same applies to this. When I say Q from P, I mean you are starting from P going to Q. So you can go to P, this is where your P is, and then draw an imaginary north line parallel to this. So a north line is always facing up, so it should be parallel to the other north line. So the next thing you want to do is you draw an arc in the clockwise direction. By clockwise direction, I mean in the same direction as the arms of your watch or your clock. So from here, you are moving in this direction all the way to Q. So my Q is here, and the line connecting Q and P is this one here. So I'll draw a line starting from my imaginary north all the way to to Q, which is this. So my job here is to find this angle here. So to find this angle, of course we know that this is a straight line. The north line is a straight line. That means you have 180 degrees this side. And then you need this other part here, the other angle. So to find this, you can see that we have a Z here. So that means you're dealing with Z angles. If this is 157, then this will equally be 157. So for you to find this entire thing, you can combine this with this. And that process of combination is known as addition in mathematics, as you may have guessed. So you can say this plus this, you have a 7, this plus this, you have a 3, carry 1, this plus this, you have a 1 plus 1, that's a 3, and this is your bearing. And you're done. So if you have 3 figures, then well and good, you can just leave it like this. But if you have 2, you have to put a 0 somewhere. So let's see what part B is requiring you and me to do. So here we want to state the bearing of A from B. So that means you are coming from B going to A. So what you do is you go to B, like I said earlier, you go to B and then draw an imaginary north line. But fortunately, you already have a north line on B, so you can just go ahead and take the next step, which is drawing an arc from the north line in the clockwise direction all the way to A. So by A, we mean the line joining B and A. So I'll draw my arc like this, going all the way to, so this is where my A is. So my job is to find this angle here. So to find this angle, you know that if I was to draw an arc from here going all the way to my north line again, that would be 360 degrees, right? Yeah, so to find this part, all you need to do is remove the 50 from 360. Then what you have remaining is this. It's like having a pizza like this. And then the moment you remove this slice here, you remain with this. So that's what we are doing here. You have 360 degrees, and then you are removing, or in other words, you are subtracting a 50. So let's find out what we have remaining. So you can say 360 minus 50. So this minus this, you have a 0. This minus this, you have a 1. This minus this, you have a 3. So this is 310 degrees, and you're done. And then on part B, we want to find the bearing of B from A. In other words, you are coming from A going to B. So to find this bearing, you can just go to A, like I said earlier, go to A, so this is where your A is, and then draw an imaginary north line like this. Then once you draw this line, draw an arc starting from A, the north line here, the north line for A, going to the line connecting A to B. So in other words, you are coming from A going to B. This is your line B. So you can say this. So this is the angle you're trying to find. So now to find this angle, there are so many things you can do. Of course, you know that this angle plus this angle is 360. I mean, you have a 90 degrees because these two are complementary angles. So that's the easiest way out. But if you can't see it that way, you can extend this one like so, and then you use Z angles. So there are so many things you can do. Just do whatever is easier for you. Provided it's correct, it will be acceptable. So now, if this is 180 this side, then the other side will be, you can just subtract 180 from there. So that's a 0, and then you can borrow a 1 from there, then you have a 3, then you have a 1. So this angle here is 130, and because we have a Z angle here, you can see that this angle will be the same as this. So if this is 130, then this is equally 130 degrees, and that's your answer for the second part. An alternative method is to call this one x, and then say x plus 50 is equal to 360 degrees. I mean 180 degrees. So you can say x plus 50 rather is 180 degrees, and then you can solve for x by taking the 50 to the other side. So this will equally give you 130. Just use whichever method is easier for you. You always have a wide range of options. And then on part C, find the bearing of Q from P. So as usual, go to P. This is where your P is. And then draw an imaginary north line. Luckily, that imaginary north line is already there. So I was adding extra questions. In most cases, this is stated. I think I got this one from 2024 math paper 2. I don't know if it was internal or external. So to find the bearing of P from Q, like I said, you draw a north line on P, but luckily for you, that north line is already there. So your job is to draw an arc starting from P. This line, this north line there is your P. So start from the north line on P, and then moving in the clockwise direction, you go all the way to Q. So this is where your Q is. So you can go all the way to Q. So this is your Q there. And then to find this angle, of course, you know that this is a straight line, and that when you add this to this, you should get 180 degrees. So to find this angle, which is the bearing of Q from P, you can simply subtract 50 from 180. So you can say 180 minus 50. So this is a 0, this is a 3, that's a 1. So your answer here is 130 degrees. You are subtracting because the straight line is composed of this part and this part combined. So for you to find the other side, you have to remove this part from 180 to get that. And then on the second part, we have the bearing of P from Q. So in this case, you go to Q. Remember, Q to P. So you go to Q, and then you draw a north line like this. This north line will be parallel to this. I'm making it a broken line because it's an imaginary north line. It's still okay if you make it solid. I'm just trying to differentiate it from the other one. So now, to find this bearing, I'll draw an arc in the clockwise direction from my imaginary north line all the way to P. So I can move from here all the way to P. This is where my P is. So my next task or my next job is to find this angle. So as you can see, there are so many things you can do. Once again, you have a Z angle here. So if this is 50 degrees, this is also 50 degrees. So to find this angle here, you can just say the full circle here, or the full revolution, is always 360 degrees. So you can say 360 degrees, and then you want to remove this small portion so that you remain with this bigger portion. You can just subtract a 50. So this is just one way. Another one can see it differently and still get the same correct answer. So 6 minus 5, you have a 1. 3 minus nothing, you have a 3. So this is 310 degrees. An alternative is to say these two here are complementary angles. So when I add this to this, I should get 180 degrees. So in order for me to find this, I can just subtract this from 180. I'm just giving you an alternative. If you're not okay with this, you can even skip it. So this one will be 130 degrees. And then to find the entire thing, you can find the sum of this and this. Remember that this is a straight line, so this is 180. So you can say 180 plus 130, you still get 310 degrees. So let's just solve the last example, and then I can give you some work. Okay, this is the last example. It's a bit different, but the procedure is still the same. So this is part of the north line. It was stated in the opening statement, but because I summarized the question, I decided not to write it. I knew I would state it. Okay, so to find the bearing of J from H, you go to H. This is where your H is. And then you draw an imaginary north line. So in this case, you can just extend this line like this. So this would be your north. And then you draw an arc from H going to J. This is where your J is. So you can draw an arc from here going to this line there. So now to find your bearing, as you may have guessed, you can simply subtract a 40 from the straight line, which is 180. So you can say 180 minus 40. Remember, this is a straight line, and then part of the angle here has been given. So the moment you subtract the 40 from 180, you remain with the other part, which is 0, 4, and 1. So this angle will be 140 degrees. And then lastly, the bearing of H from J. So to find the bearing of H from J, just go to J. This is where your J is. And then draw a north line like this. And then after drawing your north line, you can draw an arc from here going all the way to H. So this line here is the line connecting H to J. So that's where you end, like that. So this is your bearing, and then your next job is to find this angle. So to find this angle, you can see that this is a Z. So if this is a Z, then this one here is a 40 degrees. So remember, a full revolution is 360 degrees, and then you want to remove this small portion, which is 40 degrees. So once you remove the small portion, you remain with this big portion, which is 320 degrees, and you're done. So now here is your task. So find the stated bearings in the following diagrams. So this is part A. You have 35 degrees there. Then you have 155 degrees there. Then on this one, you're just finding the bearing of B from A. Then here, the bearing of B from A as well. And then the last two problems, this is a north line. So you are finding the bearing of C from D, and then the bearing of D from C. So this part was from 2023, Math Paper 1. I'm not sure if it was internal or external. And then on part D, you are finding the bearing of T from S and the bearing of S from T. This was 2022. Okay, enjoy.